Hey everyone, I'm Alec. I'm really excited to be here, but sorry if I feel a little bit out of it. I haven't really slept in a while since my son was born. That's August and my wife, and I really got to take a few seconds to just thank them for letting me disappear for a few days while I'm here. But enough about me. So chances are good that most of you haven't heard of Houdini, and so I wanted to take a step back and provide a little context of history. And that story starts all the way back in 2015. React components are still being instantiated with React.create class. Inline styles are cool. And Jing Chen and Daniel Schaefer just walked us through how they use GraphQL at Facebook to address some data consistency issues in their UI. And like most people who saw this talk, I was hooked. I impatiently waited for them to release Relay, and when it did, I pushed so hard to get it into our stack at work. And as I moved from startup to startup, I found myself teaching its fundamental principles over and over. Frankly, I became a master at justifying an obscene amount of boilerplate in the name of composable data requirements. And now, the reason I mention this is because I want to highlight something I think is pretty interesting. The version of Relay that we first got is really different from what we see now. And in that version, there was a concept of routes, and routes wrapped a particular query. And at the time, this name felt really weird to me, but it sat at the back of my head and it influenced me in ways that I've only just started to appreciate. For a brief moment, we got something that we would not see until much later when Next.js released their server components implementation. So fast forward to 2021. I'd been a happy Relay user so far, but I was looking to learn something new. I ran into Svelte and its sibling framework SvelteKit, and I quickly became obsessed. I again started building everything I could with it. Eventually, the time came to integrate Svelte and GraphQL. And I really struggled to integrate Svelte and Relay. And after trying the other options, seeing what the community had, it turned out that none of the clients could really offer what SvelteKit was trying to do with server-side rendering. There was just a big incompatibility. And so I decided to build that missing piece in my Svelte stack. Okay, so I called the project Houdini. The general idea was to make as much as possible disappear to the compile step. And fragments are the primary building block for your queries in Houdini. As you probably expect, we have a compiler that goes and composes all of these together. And there's a lot already written out there about the virtues of collocated fragments. So I don't want to go too deep into that right now. And don't worry if you don't understand the Svelte magic going on. There'll be a React equivalent later. I do want to mention, though, that every fragment in Houdini gets its own subscription to the cache. And so a component is only going to update if the information that it wants has changed. Another use case I wanted to address really early on is mutation results. Sure, it was pretty easy and standard to take the value from a mutation and update something that was in your cache, but things always got a little awkward when it was time to take a value from that mutation and insert it into a list that had been cached. And so here's what happens in Houdini. First, you tag the field with @list and you provide a name. If you're from Relay, that probably looks pretty familiar. Where things differ, though, is that once you have passed that name, all you have to do is pass this fragment that Houdini defines for you. So the name of that fragment matches the same string that you passed in, and it acts as an instruction to the runtime to take that value and insert it there. And one of the neat things about this API is that we can guarantee that your mutation has all the fields that it needs. There's no opportunity for you to have forgotten a field or have to go to that mutation and update what needs to be asked for. We also provide first-class support for pagination for more complex situations like with connections, but also simply just using offset and limit. Either way, all you have to do is decorate the field with paginate, pass a value for the initial page, and then call load next page when you want the next set of results. And for those of you wondering, we do support paginated fragments. So eventually, I joined up with Jean-Yves here in the front, and together we worked down our list of features that we wanted for Houdini. So as we approached parity with Relay, at least for the parts that made sense for Svelte, I turned my focus onto React. And I wrapped up the existing cache infrastructure and some queries that seemed to make sense at the time. Just like we saw before, use fragment, pulls fragment information for a given reference, and it creates its own subscription to the cache. And I wired up automatic typing for the use query hook. Notice there's no generic argument needed in that second example. And this was pretty cool, but things got rough once I wanted to build larger examples that had multiple pages. I did what I usually do. I reached for React Router, but I quickly found myself really disappointed with the outcome. I had to manually wrap every route in a suspense boundary, and even if I did get over that boilerplate, because React Router is not built with suspense in mind, there were many things that just weren't possible. But if I shouldn't use React Router, what should I do? What should I recommend Houdini's users to do? I didn't want to set them up to just be frustrated, because then I'd have to deal with their issues. But building a router didn't really feel like something I should just take on. It's a massive undertaking. You have entire companies dedicated to it, and so it better have a good reason. Maybe I should just stop thinking about this. Maybe I should just stay in my happy svelte bubble and just forget about React altogether. But then I saw this tweet. So Dan is specifically calling for more GraphQL clients to adopt Relay's compile time approach to fragments. And it reminded me that for most people out there, Relay was the only client approaching fragments how they were designed to be used. But beyond that, there are a few things that Houdini does do a little differently from the rest of the clients. And if I wanted to share those ideas with you all, it probably needed to be in the context of a React project. And so I decided to build that router from the ground up. And over time, I realized that this was actually a really great opportunity. I was really proud of the developer experience that we had built in this Svelte ecosystem. And this was a great time to sort of show everyone sort of this new way of approaching things. So my first decision was a pretty easy one. I knew I wanted to build on top of Vite. I was already familiar with its plugin API, and it meant I could leverage the existing Vite plugin that we had for things like automatic code gen and remote schema watching. And I didn't have to worry about hot module loading or bundling assets or any of those details. But more importantly, building on top of Vite gave me hope that my users wouldn't be left behind if they weren't using some of the giants like Remixed and Next. The Vite community is really large. There's a lot of plugins out there to optimize your assets. And with those kind of taken care of, I could just focus on routing and data loading. So let's start off really simple with some basic routing. Like most web application frameworks these days, Houdini uses a file system-based router. And just like in Next, every route in Houdini is defined by a page file. Where things do differ a little bit, though, is that in Houdini, our special file names are prefixed with a plus. Ooh, that's kind of small. It's a simple trick, but it avoids your project's files from potentially conflicting with things that we introduce in the future. Part of the challenge in a file system-based API is that becomes our API, and so we need to make sure that we are free to introduce things like, we don't need to spoil things, but we're free to introduce things without worrying about backwards compatibility. It also groups all your magic files together. And so like as you're navigating through your directory structure, you can kind of see what's going on really, really quickly. And you don't have to ask yourself, oh, is loading TSX a Houdini thing? Is that a, no, everything with plus, that gets marked as a Houdini thing. And this one little character felt like unproportionately weird to me when I first saw it in SvelteKit. But I think by the end of this talk, you should be properly distracted. And like that plus should not be in your mind at all. Anyway, with just this one file, your application will have a single view visible at the index of your server. To add multiple routes to your application, you just create multiple plus page files. As you can see, this application has 4 routes corresponding to each one. Eventually, you'll want to share some bits of your UI across your pages. To support this, Houdini lets you define a component in a plus layout file. They look a lot like view components, except they receive a children prop, which is obviously the child components that need to be all composed together. Oh, I pressed up, not down. So layouts can also be nested, and Houdini will compose your components together to create that final view. If you're new to a file system-based router, I think this diagram is really, really helpful to keep in mind, and we'll add a little bit more to it as we progress through the talk. Okay, you can finally query some data. So just like you use JSX files to define your views, your queries are defined in GQL files. And let's start off simple with a single query. Here we have 2 files, plus page.jsx and plus page.gql. In our GraphQL file, we've defined a query named allShows. This time, our view component just accepts a prop with the same name. Notice there's no need to remember the name of a hook. There's no data attribute to drill through. And one of my favorite things about this API is our UIs are finally back to being a pure function of data results. And this means that testing your UI is really trivial, and I don't have to wire up a bunch of things to give it to you. You can just import your component, your favorite testing framework, and you're off to the races. So just like we can move shared view logic to layout components, we can do the same thing for queries. A really common use case for this is to look up some profile information for the current user. And by putting this inside of a layout query at the very root of our application, all of our pages can access that current information without worrying about how they're going to get it from their parent. So to see this in action, let's imagine we have 2 queries. session and all shows. And I know that might be spaced out weirdly, but hopefully you can see sessions on the top, all shows, views on the right. So if we want to enforce that this view is only visible when a user is logged in, we can just check if the viewer field on session is defined. And if not, we can render our all shows thing. All right. Let's quickly cover dynamic routes and query variables. I know I'm going really quick, but I've been like at 30 minutes, so I need to keep moving. Route arguments can be encoded in your path using brackets in the directory name. And here you see that this one file only matches slow slash and then an ID. And because only a page file is defined, we don't even match that bottom one, which is a subroute of the shows page. Now, if a route contains a query, and that query variable matches the name of your route parameter, Houdini is going to automatically wire those things up for you. You don't need to write the function that parses a string, passes it. We found ourselves again and again writing functions that were just return ID equals params.id. It's like, why are we doing that? So those two files are everything that you need in order to say /show/1 takes me to just shows the name. Arguments can be used in multiple queries as long as they don't conflict somehow. So you see that bottom query has an int instead of an ID. There's not a consistent way to parse that. So, all right, let's just cover TypeScript really quickly, kind of get that out of the way. All the examples that I'll show today are in JSX, but TypeScript is totally supported because, again, we're built on Vite. Houdini generates types for all of your documents, like as if you were using GraphQL CodeGen. But how does that work for a route with multiple queries, multiple documents? So if we look at the example from before and convert it into TypeScript, you'll see that there's this kind of strange relative $types import. And that file contains a page prop type, which has all of the props that our page could accept. And as we add new files or as we change our queries, these types are automatically generated for us thanks to that Vite plugin. And a cool side effect of this is that you can rely on your editor's autocomplete to basically guide you through Houdini's entire API. You don't have to go to the docs. You can, of course, if you want to see our very verbosely written text. But by and large, you should be able to just get away hacking away in VS Code. Eventually, I'd like to build a plugin so that these things are automatically inferred. I just haven't found the time. If that's something you're interested in, please reach out. All right, so up next is loading states, but before we get there, I want to make sure everyone is at least somewhat familiar with React's suspense component. I know suspense has been around for a while, but I'm not sure how much familiarity people have, so please excuse me if this is something you already know. The suspense component is exported from React, and it accepts two props, fallback and children. Its job is to basically define a boundary in your component hierarchy. You see, React's rendering can be asynchronous, and so there might be a situation where React has to pause and has to wait for some other task to resolve. That could be because a component is waiting for data to load or something entirely different. Take this example that uses Houdini's useQueryHook from before. When the parent first renders, the suspense component just renders its children. Then the child component renders, and useQuery is called, which triggers the queries to be fetched, causing the component to suspend. So when that happens, our component stops rendering, and it instructs React that this component isn't quite ready. It might be helpful to think of this as like throwing an exception in a JavaScript function. It's going to terminate the execution right there where it happens. And when that happens, React will walk up the component hierarchy, and it'll render the first fallback that it finds. So if we take a look at this example side by side with a non-equivalent suspense example, we can really get a feel for what's going on under, at least what it's doing at the surface. Both examples show a loading state when the component query is pending. And the important thing to keep in mind when you're looking at that example on the left is that that fallback will show if any child suspends for whatever reason. Unlike the example on the right, where each loading state has to be tracked independently. Now, what ends up happening is that as your children need their own loading states, sometimes visually it doesn't really fit. You need something that, it's like on the right column, but you really want your loading state to be the whole page. And so this kind of inversion of loading states, I think, is quite powerful. Okay, there's a lot more to suspense, but I don't want to go too deep right now. What I do want to do is take a look at two of the components that we used in that suspense example. And right away, we can see that these components have to duplicate this layout. And in that example, it may not seem like that big of a deal. But as your UI gets more and more complicated, this split in your components is actually a lot of boilerplate to maintain. If we wanted to try to clean this up, we have two options out of the box. The simplest is to just define a query that takes two props, data and loading. And when loading is true, we just ignore data, we render a loading state.
With that defined, we can just use this one component in our fallback and in our final UI and just move on, right? I'm not sure about you, but that didn't really leave me with a great feeling. If we look at this a little bit closer, what we'll see is that the core of this issue is that while we're loading, like I said, data's useless. But what if we could do something like this? If data always has a useful value, all we would need is some kind of magic for us to identify if we're rendering the loading state of a show or the record from a database. And with all of that wired up, this one component could drive both the final and loading UIs. We could wire up our component before and pass in some mock structure to use while loading. But maintaining that value by hand is arguably worse. And we still don't know what to do about those crystal balls. So thankfully, Houdini can generate that structure for us using the loading directive. Now, the idea is pretty simple. Anything we decorate with loading will be present in the loading state of our query. So here, when the show info query is pending, data will have a single key that points to a magic value that we'll talk about later. If you tag multiple fields, each field will show up. When loading falls on a nested selection, the deepest fields are assigned that loading value, so we can still have that same core structure and use it to create our loading state. This also applies to lists. So if we instead tagged one of the fields inside of the show object, we would see a nested structure instead of that flat list we were seeing before. Oh, did it again. And we can even customize the number of entries that are generated using the count argument. Okay, so let's see how this all gets pieced together in Houdini. Here's a route that we were looking at earlier. Since we want to define a loading state, all we need to do is tag shows with @loading. With that, our loading state is an object with one key that is a list of 3 values. All that's left now is to import isPending from $Houdini, and we can easily distinguish between the loading and normal states of both versions. When the application loads, we see a state while the query is pending. And once it's done, we see the final list. And really, that's all there is to it. All you have to do is tell Houdini that there's a meaningful way to represent the loading state of your query, and the rest is taken care of for you. When Houdini encounters this loading directive, what it does is it adds a suspense boundary in the component hierarchy that we were looking at earlier. And you can see on the right that it uses the same page component as the fallback, except now this time the prop is set to that loading value. And now there's a pretty cool implication of this that I wanted to explore. Let's take a look at a quick example. This is a screenshot from a very simple demo that you can either find at that link down below or at that QR code. At the top, we show the current user in a billboard for a show we think they might be interested in. Down below, we provide a list of a grid of shows organized by genre. The thing I want to focus on right now is that not all of this is totally necessary to provide something for the user. And if we want our view to load as quickly as possible, ideally we should only wait for the bare minimum. And then we can let the rest load in and stream from the server as that data is ready. And Houdini makes this super easy to do with loading. So let's see that in action. Okay, so the trick is to split that view, the query up into 2 parts. So let's just think about them as separate queries for now. Obviously, we could use defer, but that's for another time. The first query will just load all the necessary information. And that means we need the user avatar for the current user and a billboard for whatever content that we're recommending. All of this data is necessary again, so no loading states. Our layout component just needs to take those values from the query and thread it to the relevant components. The second query will get all of the shows in every genre to build that grid. And as I said, it does have a loading state because we'll want to show that thing while we're waiting for the query to resolve on the server. And so the page component is just responsible for loading a rendering state of the grid when appropriate. The thing to notice here is that we're using the genre's name to identify a loading genre, but we can use the full show reference to identify a loading show, and that's because of the way that we used the loading directive. So if we look back at the component hierarchy, we'll see that what this does is put a suspense boundary between the 2 components. And when we render this on the server, that suspense boundary tells React to flush everything it's seen up until then. It uses the fallback in place, and when the values finally load, the final UI is streamed in, and the client replaces the fallback. Okay, so here's a video of me loading that initial render and then just refreshing continuously. So as you can see, the initial render does contain that first query. There's no loading directive, so that query actually blocks the render, unlike the second query, which does have a loading state. I filtered the network activity on that tab to only show
documents and fetches because there's a lot of noise as all those images load in. But the thing that I want you guys to see is that the data for the second query comes in over the same response that we got the initial one. And for those of you who are really concerned about multiple queries, I want to stress that these could have been sent as a batch of operations. They could be with defer. I really just want to think of these as a logically separated requirement rather than a hardcore different network requests. So a common question that I get is how the loading directive refers to the defer directive. So I just think it's probably good to talk about that for a few seconds. For those of you who don't know, defer is a directive that lets you mark certain parts of your query as lower priority. So the server is not going to block while we wait for those fields to resolve. But even with certain fields being deferred, you still need to render a loading state. And while the non-deferred, you still need to render a loading state while the non-deferred fields are resolving. And that shape of the loading state doesn't really depend on some lower level optimization of the network request, like, oh, these things are more important than these other things. The loading state is much a structural thing about what do I show while I'm waiting for those results. And so I think the easiest way to see this is to consider the pattern we saw earlier. The defer directive removes the need for the separate components, but again, we still need something to pass to that fallback prop, and that's where the loading directive comes in. And so I really think that these two are like perfect matches for each other. Defer helps you choose what fields are important, and loading helps you render that loading state while the important fields are loading. Okay, so the last API that I wanted to show you isn't really implemented yet since it relies on some undocumented React features that are just too unstable for a new father to investigate. So before we get there, I wanted to show you what is implemented. So mutations are pretty simple in Houdini. They're probably what you're already expecting. You wrap a GraphQL query and use mutation, and you get an async function that you can just pass values to. But things get kind of nasty when there's more than one input involved at a time. To streamline this a bit, Houdini is going to provide a new hook called useMutationForm, and the primary goal is to remove all that boilerplate by providing some utilities that take care of the plumbing. However, we can do some pretty neat things behind the scenes here and leverage the work that the React team has been doing on progressively enhanced forms. You see, we can follow the same practice as next server actions and set the action prop to a string during the initial render. This value would point to an endpoint that we generate on the server that will actually trigger the GraphQL mutation and send the response back to the client. When the client hydrates, it would be replaced with just a function that triggers the mutation from the client, because you don't really need that extra hop in a GraphQL application where you always have an external server. And so what this means is that if the user is filling out the form, maybe they're on a mobile device or they have bad internet, that submit button will still work even if React is still waiting to hydrate. And this is just one example where we can streamline a lot of things by saying we will be a full GraphQL framework. You're building a GraphQL application. GraphQL shouldn't be an afterthought in your code base. It should be a primary citizen. And that's really all there is to querying and mutating data in Houdini. But just to recap what we've seen so far. Routes are defined with +page and +layout JSX files, or TSX files. Queries are defined in +page and +layout GQL files. Fragments are defined with the useFragment hook. Mutations are defined with the useMutation hook, and eventually useMutationForm whenever React 18.3 gets released. And the hassle of suspense has been simplified using Houdini's loading directive. Of course, there's a lot we didn't cover, but I want to take the rest of my time to dive a little bit deeper into some of the things Houdini is doing behind the scenes for you. So to start, let's just talk about waterfalls in general. For those of you who don't know, a waterfall usually refers to this pane in your network tab. And more specifically, it's used to refer to a situation where this diagram looks like this. You see, when we have one request that's blocked by another request, chances are good that we're wasting a lot of time. We most likely could have sent all of that together, and worse, when that happens, we tend to have this cascade of loading states that can be really, really jarring. Suspense does help us fix that to some degree, but it's still not perfect. Ideally, we'd prefer it to look like this. But pulling that off requires that your application not only understand the data requirements for all your pages, but also be tightly integrated to your bundler to know how things are going to get split up and how things need to be composed back together to create that final version. Wiring that up manually is pretty tricky, and so it's usually just pushed off for a problem for tomorrow. But frameworks like Houdini are perfectly set up to address this for you. And there are two kinds of waterfalls that I wanted to address today: query waterfalls and asset waterfalls. And I think these two situations are really helpful to keep in mind when you're evaluating a particular architecture for your front end. And so let's just start off by looking at query waterfalls. A query waterfall happens every time you have two nested components that query data when they render, or maybe you have one component querying two things. Here's an example that uses the useQuery hook that we were looking at earlier. First, we get the current user session. And then in order to provide that value to child routes, we have to embed it in context and then make some custom hooks to dress up the access. And then the child component has been stripped down a lot just to show the important bits. So after loading the session from the parent, it then fires its own query to get just the information that it wants. If the user's not logged in, it redirects. And so now, when our view renders, the parent component first renders, sending that parent query. And then the child renders to fetch its second query. And so the problem here is that our application doesn't know that this page needs both of these queries in order to fire. So if we want to be able to fix this problem, we have to determine that list of the full set of queries for every possible page in our application. Right now in Houdini, this is done with some pretty simple static analysis. Take this query from earlier, for example. Houdini looks at the props that have been asked for, and it uses that to define the list of queries that you depend on. We do that for every component in your project. So when the user visits a URL like /show/search, we know that that corresponds to a particular composition of components from our project. Each of those components has their own set of queries that they depend on. And so we can make sure that when our view is rendered inside of the Houdini router, it knows that we need to trigger all three of those queries before we actually render anything. Once the queries are finished, each result gets passed down to the appropriate component. Now, I do want to reiterate again, 3 separate queries, batch, defer. I don't need to keep repeating that. Either way, hopefully you see that you have to be really intentional to create a query waterfall with Houdini. They aren't impossible, as we saw earlier with the useQuery hook, but if you really rely on the routing and data loading APIs, you're really unlikely to encounter one. And with query waterfalls out of the way, it's time to talk about asset waterfalls. Asset waterfalls occur when you have to load a script before you can fire your view's query. And this is especially tricky to address if you're just using something like V to kind of homebrew your own thing together. The most common source of asset waterfalls that I've run into is React's lazy utility. Now on the surface, lazy looks pretty good. You pass a function that returns the result of importing a component. When Vite sees that dynamic import, it splits your application into multiple chunks. While the file is loading, the component suspends, and when it's finished loading, the results get rendered. So let's imagine our route looks something like this. If we string those two actions together, we'll see the first thing that happens is that React renders the loading state while we fetch the assets for the component. And then it replaces the child of suspense with home, which also mounts suspends again and then sends a request to the API for our data. So you see, since our route doesn't fire until the query is rendered, and our query doesn't fire until the component has been rendered, there's no way for this to have happened in parallel. So how does this work in Houdini? Well, I didn't really want to make you guys stare at more network pains, so you'll just have to trust me. It works. But that being said, if we take a look back at one of the examples from earlier, I think you can get a good idea for why this isn't a problem in Houdini. Notice that this component doesn't actually suspend. It doesn't really do much at all. There aren't any calls to lazy anywhere in the application, and all of the details about how to split things up, how to bundle them, when to suspend for what data, it's all just tucked away behind the file system-based API. And that means you can really just focus on your business logic, and we can ensure that your application is split up correctly. I think for a lot of situations, a file system-based API feels more like a stylistic choice. But I think for a GraphQL application, it's a crucial way to solve a real problem, which is that your component that wants data can't be the thing suspending. The suspense has to happen outside of your component. And so your component source needs to be pretty decoupled from the actual query that's being sent. And so by tucking it away into the props and in other files in our file system router, it kind of naturally falls into place. Ooh, out of time. Okay, so I think it's finally time to address the elephant in the room. I'm gonna try to go quick here. And that's server components. So I just want to quickly say, oh, I jumped ahead. Great. So server components are really just components that have already been rendered by the time your client gets to them. That could include static components that we've pre-built so we don't waste cycles, or it can include dynamic components that the server has rendered using some remote data. And from that perspective, I think server components make total sense as a way for us to pre-compute expensive parts of our tree and bundle them away. And so we're not constantly wasting time rendering them. So for those of you who don't know,
This tweet was part of a massive set of Twitter threads where Dan explored the virtues of server components until like 8 a.m. his time. And again, he used the term framework to mean something that lives at the intersection of a router, a bundler, and a data fetcher. And I think it's important to remember that Next.js's app router is just one implementation of such a framework. The Next team tailored their solution towards users who don't have an external API. So of course, for that situation, it makes total sense to put all of your data fetching and everything in the same server that's rendering your application. But I'm not sure that's the right move for us. What I do know is that the GraphQL community, we need a place to experiment with server components and how to best incorporate it into our stacks. And while I do think Houdini has some great qualities that make it a good fit to be that playground, if I'm being really honest, right now Houdini is just a fancy file system-based router that knows how to speak GraphQL. I do have a few more ideas that I think sort of round it off into that more framework, full stack place, but they're not quite ready yet. And I've also crammed way more than I could into this talk. I also wish I could stand up here and just say that this is ready to go, but that's only the case if you're using Svelte. Everything you've seen today has been implemented in React, both in development and for deployment, but there's still a few more pieces to get in place. Before I go, I just want to mention that if you want to try this out yourself, you can just run npm create Houdini, bootstrap your own project, but documentation is really sparse and there'll be a lot of dragons. That place is full of dragons. Or you can follow the QR code on the left to see the example we've been looking at today. If you want to check out the GitHub repo, you can follow the QR code on the right, and that's it. Thanks for listening. I don't think I have time for questions, but yeah, are there any? Okay. Can you refetch with useQuery? Yeah, so because useQuery needs to be the thing suspending, the state that causes the suspension needs to be in an actual component state. And so with the useQuery hook, refetching feels a little bit weird because the refetch needs to be part of the render. But there is, I probably shouldn't have disconnected. There is a way to get sort of what I call an imperative handle to the query in that same prop-based approach. In the slide about the API, there's this really ugly dollar handle. And the idea is that that's a way for you to say, I want this query, but I want a more imperative reference to it. I don't just want to take some flat reference. And that you can do things like load next page, refetch your query, whatever the case may be. Yeah. Robert?
What's the story for fragments? I didn't see any fragments in this, and I'm wondering in particular, do fragments and subroutes, are those, can you not use fragments with subroutes?
You totally can. Yeah, so I kind of breezed right through that. There was a little slide where I showed, and it's just a use fragment hook that looks exactly like Relay. Suspends if data is not present. It sort of behaves sort of in that best practice way that Relay has sort of showed us fragments should work. We have a compiler that hunts all those things down, and we sort of very much take the Relay approach to fragments.
How do subroutes with fragments? Is that possible? If you can both render the parent without the child route, but also the child route, can those be combined into a single query, or is that?
Yeah, so right now, they are treated as separate queries because I just didn't have a lot of time to do the bundling story. Fragments can still fall on those for sure. And I think one of the really nice things is that because it's not a context-driven API, you are totally free to just pull a fragment reference from your query arbitrarily deep in your project, and it'll make sure that that's always loaded for you. Cool. Thanks, everyone.